Injectable endothelial cells?
Basically, it's meant to address corneal edema. They actually impregnate them with a magnetic nanoparticle, and you put a magnetic patch over your eye.
Oh, that is so cool.
And it brings it to the target tissue. It's going to be a couple of years, I think, before it's commercially available.
From the 7th annual winter meeting of the IIRSI in beautiful Amritsar, I'm Josh Young. I'm here with my dear friend Sam Garg. Sam, we're talking about a super interesting topic, which is, and correct me if I'm wrong, it's injectable endothelial cells. So it's cool.
Correct. Yeah.
So
yeah.
There are a lot of things that I want to ask, but as a preliminary, let me just ask you: what are the pathologies that would be the utility for this?
Yeah. So this technology is being developed and has been developed outside the U.S. and now within the U.S. But basically, it's meant to address corneal edema, and whether that's Fuchs dystrophy, whether that's PBK, whether that's a graft attrition from graft just outliving its utility or its life. There's many different applications where this could be useful, but essentially it's for patients with endothelial dysfunction.
And it's for primary, for primary treatment. It's not for failed endothelial grafts or failed BKs.
Well, certainly we don't know yet. I think eventually that could be an application. Certainly for the clinical trials, I believe the entry criteria for both companies that are exploring it in the United States is going to be more simple PBK or Fuchs.
Now, where do these endothelial cells come from? Do they come from grafts? Are they grown?
So they come from human donor corneas, and then they're taken and they're processed. They're harvested, and then they're expanded. And so from one cornea you can get several hundred doses of these corneal endothelial cells.
Oh, that's marvelous. I mean, that would be a huge yield. Before you inject them, do you need to remove the dysfunctional endothelium that's there?
Great question. So there's different approaches to the use of cultured or human cultured endothelial cells. One is from Orion Therapeutics, and they're an Eyeconic company based on the work of Dr. Kinoshita from Japan. And in their case, it's a biologic, meaning the cells, as well as a Rho kinase inhibitor together combination, where you do have to go in and gently brush the corneal endothelium. The other one that I discussed at this meeting was from a company, MSL. And what they do is they take these human cultured endothelial cells, they actually impregnate them with a magnetic nanoparticle. And then those nanoparticles or the cells are injected into the eye, and you put a magnetic patch over your eye.
Oh, that is so cool.
And it brings it to the target tissue. In that technology, you do not have to brush the endothelium.
That is really neat. Yeah, I would anticipate the question that I'm going to ask next, which is when you inject the endothelial cells, how do they know where to go? I mean, don't they just all wind up in the TM?
Yeah, great question. So interestingly, there's something where they're sort of drawn to where they need to go. In this case of MSL, it's actually a magnet that helps them literally draw to where they need to go. So you put this patch on the eye, and you can be seated up, or however position you want to be, and the cells move to where they want to be. And then the magnetic nanoparticles get expressed from the cells and are then removed from the eye, likely from the trabecular meshwork. In the case of the Orion product, you actually have to lay face down for a period of like 3 hours, I think, after the procedure to allow those cells to settle down against the endothelium.
Do you bubble the AC or
no?
Really?
No need for a bubble. Yeah.
Huh. That's really neat. So I have patients with decompensating Fuchs and PBK, and when do I get to use this?
Yeah. So it's going to be a couple of years, I think. The clinical trials should be starting in the U.S. In 2026, likely with Orion starting before MSL. And then it takes the time that it takes to recruit the patients, follow them for safety and efficacy. So it'll be several years, I think, before it's commercially available within the United States. That being said, it is commercially available, the Orion product, in Japan. And so they've been using it in their patients for, I believe, almost the last year.
Great. So, these are proprietary products. Are there published data?
Yes.
So tell me about it.
So recently there was a paper in the Blue Journal, and actually the group, the Orion group, has several published papers on the work of Kinoshita, essentially. So, but Dr. Kinoshita has published extensively on this topic. His most recent paper in the Blue Journal showed 10-year data on safety and efficacy, and showed really favorable data. And so, I think there's a lot of promise for this technology. I think the big question is, are we going to be able to make it, are we going to scale it? It's fine if you can do this for a couple centers here and there, but in order for this to really help the number of patients it needs to help, it has to be the manufacturing, it has to be the distribution, and it has to be the safety and efficacy of the procedure. And I think, each one of these companies checks those boxes. We'll see if they can get it to the finish line.
Sam, this is so cool. It's a really, really
cool,
neat thing. I want to thank you for, first of all, for working on this really cool thing and for describing it to us. But most of all, I want to thank you for the generosity of your time with me today.
Thank you very much.